Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of EC at K.S. Rangaswamy College of Technology. In this lecture, we are going to see about two topics, cyclic redundancy check and checksum in the course Computer Networks under the module Data Link Layer. The central concept in detecting and correcting errors is nothing but redundancy. In order to be able to detect and correct errors, we need to send some extra bits, nothing but redundant bits with our data. These redundant bits are added by the sender and removed at the receiver. Their presence allows to detect and correct the errors at the receiver side. There are four types of redundancy checks used in the data communication. First one VRC, second one LRC, third one CRC, cyclic redundancy check, and the fourth one is checksum. In this lecture we are going to see about cyclic redundancy check as well as checksum. The cyclic redundancy check coming under cyclic codes. In a cyclic code, if a code word is cyclically shifted, the resultant result is another code word. That is, if it is a 8-bit code word, if we cyclically shift left each bit from LSB to MSB and the MSB bit will be available at the LSB bit, we can get another code word. This is a cyclic redundancy check is mainly used in LANs and WANs in order to correct errors. And also, if the data word is a 4-bit and the code word will be of 7-bit. CRC, the CRC can be, CRC operation will be explained by CRC encoder as well as decoder. The CRC encoding is performed at the sender side, decoding is performed at the receiver side. With the data word, we generate augmented data word, and this augmented data word where the number of zeros are appended at the end of the data word, and which will be given as an input to the generator where it performs division operation with the divisor which is a predefined one. The division operation will be of modulo to division operation where we perform XOR operation, and we'll be getting the remainder. We discard the quotient. The remainder will be appended at the data word, so that this will be transmitted through transmission medium. Your transmission medium will be unreliable one, and the received code word will be given as an input to the checker. Checker will perform same modulo to division operation with the same divisor. We will be getting the remainder nothing but syndrome, which is given as input to the decision logic where the decision will be made whether to accept the data word or discard the data word by means of a receiver. If the syndrome is 0, the data word will be accepted at the receiver. If the syndrome is having the value, it will be discarded. The theory is explained here, which is explained by means of an example where the divisor is 1011 and the data word is 1001. We get the augmented data word by appending number of zeros at the end of the data word. The number of zeros are appended or by having the value of the divisor, the number of bits in the divisor. If the number of bits in the divisor is 4, 4 minus 1, number of zeros are appended at the end of the data word. We perform the division operation, nothing but XOR operation. We see the leftmost bit is 1 and we use the same divisor. If the leftmost bit is 0 and we use the divisor 0000 and we get the remainder. If the remainder, the nothing but CRC is appended with the data word as a code word. This code word will be using the same divisor to perform XOR operation, and will we get after division operation we'll be getting the syndrome. If the syndrome is 0 and a corresponding data word will be accepted at the receiver, assuming there is no error. During transmission there may be of changing of the bits. Here in the second case the fourth bit 1 is inverted to 0, so that when we perform a division operation we'll be getting the syndrome, so that the receiver identifies that there is an error during transmission. We can perform the CRC operation by means of a polynomial. How to represent a polynomial? To represent a binary word. If the binary word is 1000011 and we multiply each coefficient from a0 to a6, a0 is multiplied with x power 0, a1 is multiplied, the coefficient of a1 is multiplied with x power 1, so that a6 coefficient 1 is multiplied with x power 6, and we discard the coefficient zeros and we take the coefficients 1 and with the power term. So 1 into x power 6, 1 into x power 1, 1 into x power 0. So we will be getting the other remaining power terms with the coefficient 0 are discarded, so that we will be getting the short notation x power 6 plus x plus 1. And checksum. So in this, how to calculate checksum? With the checksum, how to identify whether the receiver have to accept the data or discard the data. So with the idea and one's complement, we can explain the principle. Suppose our data is of list of 5 4-bit numbers 7, 11, 12, 0 and 6. We add in the center side, we add the sum of these 5 4-bit numbers 36. And the receiver side, the receiver adds the 5 4-bit numbers and it will check with the sum 36. If it is equal, the receiver identifies that there is no error, so it will accept the data. The idea can be explained with the ones complement, where instead of sending the sum at the center side, we send the negative of the sum, that is minus 36. That is otherwise called a checksum. And the receiver adds all the 5 4-bit numbers with the checksum, and if the result is 0, it assumes that there is no error during transmission. So before going inside the example, it can be start with how to represent the number 27 in ones complement arithmetic. In ones complement arithmetic, the number 21 is represented with 5-bit numbers. So we need to represent it only with 4-bit, so that leftmost one will be wrapped and it is added with the rightmost LSB, that is 0101 plus 1, so that 0110 will be getting the decimal number 6. So how can we represent the number minus 6 in ones complement arithmetic? Ones complement arithmetic, the positive number is 6. Positive number for 6 is 0110. Negative number 6 can be represented with 1001. That is by inverting or finding the ones complement of this binary word 6. So this principle is used here. For example, from the center side, we are sending the 5 4-bit numbers 7, 11, 12, 0 and 6, but the initial checksum is 0, and by we are adding all these numbers, we get the sum as 36, and we convert this 36 with the binary word, and we'll be, since these are all 4-bit numbers, we need to convert this uh, the binary word of the 36 6-bit number to be a 4-bit number, so that leftmost bit 10 will be wrapped around with the least significant bit, and we perform addition operation. 0 0 0 is 0, 0 1 is 1, 1 0 1 is 1, 0 is 0, so that we will be getting 6. We'll be getting 6. So this 6 and this 6 will be we are performing ones complement, so that 0 will be inverted to 1, 1 will be inverted to 0, so 1 to 0, 0 to 1, so we'll be getting 9. So this new 9 will be the new checksum instead of this 0, and this 9 will be inserted as a new checksum with the 5 4-bit numbers. And we perform the same operation, we get 45 as the sum. Once again we convert it into binary, and we find the wrapped sum as 15. 15 will be in the binary 1111 will be inverted for the ones complement, so that we'll be getting 0000. Now the checksum is 0, so that the receiver identifies that there is no error during transmission. Can be explained with the character for Rosan. So we are it can be represented with ASCII numbers 46, 6F, 72, 67, 75, 7A, 61, 6E with the initial checksum 0000. We are performing addition operation for each columns, and the leftmost bit 1 will be wrapped around. We'll be getting 6 plus 1 as 7 as sum. So 8FCF will be the sum. We are performing ones complement arithmetic operation, so that 7038 will be the new checksum, which will be sent to the sent to the receiver, and instead of this initial checksum 0000, now the new checksum is 7038, so that we are performing addition operation in each column, so that leftmost bit 1 will be wrapped around, we'll be getting the sum as FFFF, and the new by performing one's complement operation, we are getting the new checksum as 0000. If the new checksum is 0, the receiver identifies there is no error during transmission. So with the concept we have learnt, we are going for some MCQs. The main concept behind error detection in data communication is CRC is widely used in. So the answers are redundancy. CRC is used in LANs and WANs. If a code word has 7 bits, the data word is 4 bit. The redundant bits are 7 minus 4, 3. CRC encoding division performed by modulo to division operation. CRC, the remainder produced by the checker at the receiver is. In CRC, if the syndrome bits are all zeros, the result is syndrome and no error is detected. If checksum, the negative of the sum sent with the data is one's complement. If the receiver adds all numbers including checksum, the result is 0. There is no error during transmission. So the last one, in one's complement arithmetic, negative numbers are represented with one's complement, that is inverting all bits. A binary word can be represented as a polynomial where rightmost bit will be the x power 0. So 0 power 10. Thank you.